Alright, so for part 1 of this problem, I'm going to be using Newton's laws in order to find the solutions to part A and B. So we're given information that we have a 12 pack that is of mass 4.3 kilograms. It's initially at rest on a horizontal floor, so the initial velocity is 0 meters per second. It is then pushed in a straight line for 1.2 meters, so the total distance equals 1.2 meters. And it's by a trained dog that exerts a horizontal force of 36 newtons. So we'll call that an applied force of 36 newtons, and it's constant for that duration of 1.2 meters. So in part A, we're asked to find the final speed, given the assumption that there is no friction between the 12 pack and the floor. So we'll consider force of kinetic friction to be 0 newtons. So first of all, we're going to draw a free body diagram of the situation. So there's my 12 pack. You have a force of gravity going straight down and the normal force going up. It is resting on a horizontal floor. And I'm still going to draw the force of kinetic friction here, even though we consider it to be 0. And we have an applied force going in this direction. So I'm going to define my coordinates here. And of course, acceleration is going to be in this direction. So we're going to write the sum of forces in the x direction as just being the applied force, which is equal to max, as we're considering force of kinetic friction to be 0. And then we have our sum of the forces in the y direction equal to Fn minus Fg, which equals may. And of course, there is no acceleration happening in the y direction, so this is going to be equal to 0 newtons, which means Fn equals Fg, as those forces are directly canceling each other out. But that's not really important information here for part A. I want to go back to the net force in the x direction, because we know that this is 36 newtons divided by 4.3 kilograms equals the acceleration in the x direction, right? Just plugging in the values there. And that's going to be important information to find the final velocity, so I'll plug it into my calculator. Get 8.37 meters per second squared. So using that information that we found, we can use a kinematic equation at v of x squared equals v initial x squared plus 2a x final minus x initial. Now we know that the v initial is equal to 0 meters per second. The acceleration, we know x final minus x initial is just the distance, 1.2 meters. So we're going to be able to solve for v of x. So we're just going to plug in these values here. I'm going to use my calculator to find that value. And I'm taking the square root. 4.48 meters per second is the value that I find for part A. And so part B, we have the same situation here, but we're considering the force of kinetic friction to be present. So it's non-zero, and the coefficient is provided as 0.30. So I'll do the problem here. We're going to be using the same free body diagram as this situation identical. We're just going to rewrite our sum of the forces in the x direction as being the applied force minus the force of kinetic friction, which equals max. And of course, we're doing minus force of kinetic friction as it is going in the opposite direction of the motion. And sum of forces in the y direction is going to be the same. This is still 0 meters per second squared. And this is going to be useful information for us, as we need to determine what the force of kinetic friction is. So that's going to be 4.3 times 9.8 for a normal force. And using the equation, force of kinetic friction equals the coefficient times the normal force. And we were given that this was 0.3, I believe. Yes. And normal force we found is 42.14 newtons. And so I'm going to use my calculator to find that. So 12.64 is the value I get for the force of kinetic friction. And we're going to go back to the net force in the x direction equation. We're gonna solve for the acceleration again. So we have the applied forces equal to 36 newtons. The force of kinetic friction as that. We're going to divide by the mass, which is 4.3 kilograms. And that's going to equal the acceleration that is occurring here. So I'm going to plug that into my calculator. And the value that I get is 5.43 meters per second squared. We're going to use the same method to find the final velocity using the kinematic equation, since we don't have any value of time given in this, and so that's a very useful equation in this scenario. So we still have the same values for v initial x and x final minus x initial. We're starting from rest, so that's going to be 0 meters per second for our initial velocity, and we're still moving 1.2 meters in general, so we're going to be able to solve for this again. So I'm just going to plug in the values here. Plug that into my calculator. I'm going to take the square root. And that's the value that I get. And it's very important to also indicate that we're going to keep the positive value, as speed is a magnitude. And in the direction that we're asking for, in particular, speed. So go to this answer as well. So those are the answers to part A and B using Newton's laws.